right, so it's time to learn the party trick that is binary. Now, again, we are never going to program a computer in binary. It is just far too complex on today's computers to be able to do that, and you'll learn a little bit more about why. But we do need to, for this class, understand binary, understand how the binary number system works, and be able to convert numbers between our usual way of counting, which is called the decimal system, and the binary system, and back and forth, okay? So to get us started on this topic, let's just first ask the question, how do we count? ¿Cómo contamos? Contamos, right? I start with 0 because we do in computer science. 0, 1, 2, 3, right? Okay, and so within one place value, if you remember back to elementary school, and we talked about place values. If I'm in the ones place, I have 10 possible digits or 10 possible shapes that I could use to count. So I could start with this shape, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the shapes or all the digits or all the numbers that I have to use in that first place value, in the ones place. But what happens now? So I got to 9. Can I count any higher in the ones place? And hopefully you understand that the answer to that is no. I'm going to have to go up to the tens place. So once I get to 9, which is my biggest number I can possibly get to in the ones place, then I've got to bump over. I've got to start using the tens place. And I can use each of those same shapes, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, in the tens place also. And that's how I start to get so many numbers, right? So if I have 2 places, I've got the ones place and the tens place now. I can make all of these numbers. So over here on the far left side, I'm animating what it looks like just to have numbers in the ones place. But as we put our 1 in the tens place, we get the teens. And as we put our 2 in the tens place, we get our 20s. 3 in the tens place, we get our 30s, and so on, all the way up to 99. Okay, so once I reached my 9 in each case, so I got to my 9 here, I had to bump over into the tens place. That gave me the 1 in the tens place to make the number 10. Then I count up 10, 11. See, I'm moving 0 through 9 in the ones place again, while my 1 stays the same in the tens place. But once I fill that up, I'm at 19. I'm going to have to add another digit, or I'm going to have to bump up my tens place. So now I'm at 20. All the way up through 29. Now I've got to bump up to get 30, etc. Okay. So quiz, if I get into 99, what's going to come next? And hopefully you understand that the answer is 100. Okay, so in our system, our way of counting that you grew up with, we start with the ones place, fill it up, then we bump into the tens place and we fill that up. We bump into the hundreds place and we fill that up, and that's how we count. So let's take a look at what that looks like as far as kind of our mathematical notation. So we're talking here about decimal numbers. The prefix deci right here means 10. Okay, so deci means 10. So a base 10 number system has a base of 10, meaning it has 10 possible different digits. 0 counts, so 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are my 10 possible digits in a decimal or base 10 number system. So that means that my place values each have to be times 10. Okay, so I'm going to start with the ones place. 10 times 1 gives me my tens place. 10 times 10 gives me my hundreds place. 10 times 100 gives me my thousands place, and so on. So if I had a number that looked like this, 3210 in the decimal system, well, how do I know what that actually means? Well, it means I have 3 thousands I have 2 hundreds, I have 1 10, and 0 ones. If I wrote that out, it would look something like this. 3 times 1,000, because I have 3 thousands, plus 2 times 100, 2 hundreds, plus 1 times 10, plus 0 times 1, because I don't have any ones. That gives me 3,210. All right, so hopefully that was a review for most of you about how we count, the digits that we use, how our place values work. Well, guess what, guys? There are tons of different number systems. Not all of them are base 10. There are some in the world that are base 16, base 20, base 5. They're all different kinds. And all that means is how many digits do we have to work with? In a base 10 system, we have 10. Okay, but what about a binary number system? So the prefix bi means 2. Over here, deci meant 10, but bi means 2. So this is a base 2 number system, which means we only have 2 possible digits to work with, 0 and 1. So it works exactly the same way. Our place values are multiples of 10. Right? Or in our decimal system, our place values are multiple of 10. We always start with ones, but then it's times 10, times 10, times 10. In our binary number system, because it's a base 2 system, we still start with 1. Anything to the 0 power is 1, okay? But then we multiply by 2 every time. So my place values look like this. My first one is the ones place, just like I'm used to. Then I have the 2's place. How many 2's do I have? Then I have the 4's place, the 8's place, the 16's place. See that pattern? 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and so on. Okay, and then to make numbers, it's going to work in the exact same way we did with our decimal system. Over here, I've got what we know as 23. That means I have 2 10s and 3 1s. 2 times 10 plus 3 times 1. That gives me 23. So if I build a number in the decimal system, and let's say it looks like this, which looks kind of scary, well, all this is saying is I have 1 16, 0 8, so I can ignore that, 1 4, 1 2, and 1 1. How do I add that all up? Well, 1 16, so 16, plus 1 4. It's actually easier because all I have are 1s and 0s here. So I've got a 16 plus a 4, that's 20, plus 1 2, so that's 22, plus 1 1, that's 23. So 23 in decimal looks like this. 23 in binary looks like this. Same exact system, 1 times 16, 0 times 8, etc. So how would we go about counting in binary? Well, the first 2 numbers are really easy. If we only have 1 place value or 1 digit to work with, then it can only be a 0 or a 1. So I start with 0, always. In computer science, we start with 0. And then 1 would be our next. But if I only have 0 and 1 to work with, what do I do now? Well, think back. What did we do in decimal? If we got to the highest digit we had access to, we had to jump into the next place value. So the number 2 in binary is 1 0. It's tempting to say 10. Don't say 10. This is 1 0. I have 1 2 and 0 1s. Then how would I make 3? Think about it for a second. I have 1 2 and 1 1. So to make the number 3, our decimal number 3 in the binary system is 1 1. Let's keep counting for a bit. So I'm full. Do you see this? 1 and 1. I have nowhere to go in these 2 digits. They're both full. What do I have to do next? I'm going to bump it up to the next place value. Now I'm in my 4's place. So to make the number 4, it's 1, 0, 0. I have 1 4, 0 2s, and 0 1s. Okay, so let's count how far we've got so far. 0, 1, 2 is 1 0, 3 is 1 1, 1 2, and 1 1. 4 is 1 0 0. Can you guess how to get 5? You should have 1 0 1. I have a 4 and a 1. I add those together, and that's how I'm going to get 5. Now here's a tricky one. This is where a lot of my students get thrown off. How would I make the number 6? If 1 0 1 is 5, how would I make the number 6? I want you to think back how we did this. I went 0 1. What did I have to do here? Okay, so we're going to have to do the same thing. To make the number 6, I'm going to bump up into my 2's place. I've got a 4 and a 2. 4 plus 2 is 6, so I don't need any 1s. Let's do our final one on this example, and that's the number 7, which is all full here. So I want you to think about how you would make the numbers 8, 9, 10, and 11. And do those on your own.